Hey guys, I hope you're all staying safe from the coronavirus and that you're enjoying some time at home and some time away from school. Today we're going to be starting our Unit 12 probability notes. It's the last unit for geometry. Yay! So today we're going to be the 12.01 notes. You can follow along in your packet if you picked that up from me, or this is available on OneNote as well if you want to follow along there. So first thing in probability that we want to talk about is sample space. Sample space is the set of all possible outcomes. So what this really is this is a list of all the possibilities that could happen in a probability situation. So we're going to be talking about a number cube that is rolled and then a coin that is tossed. So our sample space is going to be the list of every possibility that could happen when you roll that dice and then you flip that coin. So in math, when you see the word set, that's really just a list. You're listing out all of the outcomes. So again, we're looking at a number cube that is rolled and then a coin that is tossed. First of all, what is a number cube? That's another word for a dice. Sometimes they like to use the word number cube. And the question I always get asked is how many sides or how many numbers are on a number cube? Well, a cube is a six-sided shape. So it would have 6 numbers on it. So when we are looking at our outcomes for the roll of the number cube, there are 6 possible outcomes. Because it's a cube, there are going to be 6 numbers on it, 1 through 6. And for the coin toss, there are 2 possible outcomes, heads and then tails. So there are 3 ways that you could possibly write this sample space. We could have an organized list, a table, or a tree diagram. So let's look at our organized list first. This is just literally listing it out, but again, you want to be organized. You don't want to keep writing down random numbers. So I'm going to start with my first event, which was rolling that dice, that number cube. I could roll a 1, 2, 3, 4, 5, or 6. So I'm just going to list those out. After I roll that dice, then I'm going to flip a coin. When I flip a coin, it could either be heads or tails. So I could roll 1 through 6 and then get heads. Or I could roll 1 through 6 and then flip the coin to get tails. So this is my sample space. When I'm asking for a sample space, I'm not asking for how many numbers. I'm not asking, so this would be 12 is the answer. No, that's not the answer. This is your answer. This is your sample space, the list of all possible outcomes. So if I were to roll a dice and get a 4, and then flip a coin and get heads, 4 heads would be found in my sample space. Anything that could possibly happen in that scenario should be represented in your sample space. So here's our organized list. You could also create a table in case you're worried about missing any possibilities, kind of like what we do with a Punnett square. In science class, one side is going to be 1 through 6. The other side is going to be heads or tails, and then I'm going to fill in all of these blocks, and that way I don't miss any possible outcome. So this row is 1, and then this column is heads, so in this position would be 1 heads. This row is 1, that column is tails, so this will be 1 and then tails. And you continue on listing out your outcomes until you have the whole table filled in. Once you have the whole table filled in, this is your sample space. Every possible outcome that could happen is listed here for us to see. So that was our table. We could also have a tree diagram. So this is an example of a tree diagram. You could have a starting point. I wrote outcomes there, but you don't have to write outcomes. You could just have a little starting point. From that starting point, you're going to write out all of the possible outcomes for your first event. Our first event is rolling a dice or our number cube. What are our outcomes? We have 1, 2, 3, 4, 5, or 6. All of our outcomes for rolling that number cube or that dice. From there, we're going to flip a coin. So let's say I first rolled my cube and I got a 1. I'm now going to flip my coin. From there, I could either get heads or tails. And it looks like it printed off funky. Sorry about that. It's supposed to lead to those outcomes, heads and then tails. I could have rolled a 2. Then flip my coin to either get heads or tails. I could have rolled a 3, and then I'll flip a coin to get heads or tails, and so on. From each one of these, we will have heads or tails. So how does this give me my sample space? I just follow the path, and every outlet is something that represents my sample space. It represents an outcome in that sample space. So if I rolled a 1 and then flipped and got a heads, that would represent 1H. Rolled a 1 and then flipped and got tails. Rolled a 2 and then flipped and got heads, and so on. Every single path leads to an outcome. And so once you are done, you have listed all of the possible outcomes, which is your sample space. This is your sample space. So those are the 3 ways that we could possibly represent our sample space. Let's look on the next page. Okay, so I'm going to do this example problem. If you want to at this point, stop the video, pause it, and try to do it yourself. That might be a good idea, and then check yourself with me. It may not have to look exactly like the way I'm about to draw my table or the exact order that I make my list, but all the outcomes should be represented when you're done. So if you want to, take a second, pause the video, and see if you can do this on your own. So Aaron can join the Air Force, the Army, or the Marines, and he can do that either before or after college. So I want to represent the sample space for this experiment by making all 3 of these. So let's start with our list. So Aaron can join the Air Force. I'm going to use that with an AF, the Army, or the Marines. And he can do that either before or after college. So I might kind of do a little abbreviation since we have a lot of letters here. I'm going to do before college first. And then he can also do it after college. So Air Force, Army, Marines, and he could join them after college. So here is my organized list. So this is my sample space. These are all the possible choices that Aaron could make. Now let's do our table. So on one side, I'm going to do the Air Force, Army, or Marines. And then on the top, I am going to do before college or after college. And make my little table. Make this look a little bit better. Okay, so what is going to be inside of this table will be my sample space. So here we have the Air Force before college or the Air Force after college. I have the Army before college or the Army after college. the Marines before college or the Marines after college. And there inside of my table would be my sample space. So this is my table. Okay, the last would be my tree diagram. Okay, the first choice is Air Force, Army, or Marines. So maybe I might branch off from this word. Air Force, Army, or Marines. After he makes that choice, he then needs to decide before or after college. That's 2 choices from each of these. Before college, after college, before college, after college, before college, after college. So what is my sample space? Air Force before college. Then I have Air Force after college, Army before college, Army after college, Marines before college, and then Marines after college. There is my sample space. So you can see that no matter which way you do it, I did ask you to do all 3 on this problem, but no matter which way you do it, you end up having all of the possibilities listed. There are 6 possibilities, and you get all 6 no matter which way you do it. Also, let's talk about that tree diagram for a second. If I had started with just before college and after college, a 2 split in my first branch, and then did Air Force, Army, Marines, Air Force, Army, Marines, from those branches, you would still get the same answer. So again, your tree diagram, your table, and your list do not have to look exactly like mine, but when you are done, you should have all 6 of the outcomes listed. Any questions there? Well, I guess you're not here. Okay, now we're moving on to the fundamental counting principle. The fundamental counting principle. So the fundamental counting principle is going to tell you the number of all possible outcomes. So it's not exactly your sample space. This is not going to tell you what your sample space is, but it is going to tell you the number of all possible outcomes. So the number of all possible outcomes. So the number of all possible outcomes can be found with the fundamental counting principle. Again, this is not what your sample space is, but it is going to tell you how many things should be in your sample space. So this can be found by multiplying the number of possible outcomes from each event together. So the number of all possible outcomes can be found by multiplying the number of possible outcomes from each event. So look at this number 2. Josh is making a stuffed animal. 1 from each category is necessary to make the stuffed animal. So he needs to select a type of animal, and there are 10 choices. A type of stuffing, there are 3 choices. A sound effect, there are 5 choices. Eye color, there are 3 choices. And an outfit, that are 20. Now, if you could imagine actually making the sample space like we did in the previous problem, you would have to list all 10 animal choices. Each of those would have the type of stuffing, and then 5 sound effects from there. If you were making a tree diagram, you would have to keep branching off that many. You're going to end up with a ton of branches on your tree. So actually making the sample space is not realistic for this problem. We're going to end up with a lot of branches and writing out a lot of different possibilities. So the fundamental counting principle, instead of telling us what it's going to be in our sample space, it's going to at least tell us how many things will be in our sample spaces. So how many outcomes are possible. So we're going to multiply each of these number of choices together, and that will tell us how many are possible. So first we have a type of animal. We had 10 choices. Multiply that times we have 3 choices for a type of stuffing times 5 choices for our sound effect times 3 choices for our eye color, and then finally 20 choices for our outfit. So now you want to get your calculator and multiply that together. 10 times 3 times 5 times 3 times 20. And we get 9,000 outcomes. What kind of outcomes? You have 9,000 stuffed animals. Tell me what we're talking about in this problem. So with these combinations that Josh has to choose from, he could make 9,000 different possible stuffed animals. So if you could imagine making a tree diagram or making a list or making a table of all these outcomes, we would end up with 9,000 possibilities. In our last problem, we had 6 possibilities. Here we have 9,000 possibilities. So making our actual sample space is not realistic, but the fundamental counting principle tells us how many we're going to have. Okay. So number 3, I would suggest trying this one on your own. There are some different, it's worth trying it first and seeing if you understand it before you just follow along and watch me do it. So take a second, pause the video, see if you can do this on your own. Jack is choosing an internship program that could take place in 3 different months, 4 different departments, and 3 different firms. We want to know how many different outcomes are there for Jack's internship. So first we need to decide how many what month. So there are 3 choices for the month. There are 4 different departments. So let's multiply that by 4. And then there are 3 different firms to choose from. So to figure out how many outcomes, we are just going to multiply those numbers together. 3 times 4 times 3. That is 36 internships that he could pick from. So part 2, if Jack is only available in the month of July, how many different outcomes are there for his internship? So what is changing about this problem? So we're only changing the number of months. If you look back, there were 3 different months. That was our first number. And so now we know that he's only available in the month of July. So instead of having 3 choices, we now only have 1 choice for our month. We still have 4 different departments to choose from and 3 different firms to choose from. So our number of choices has changed on that piece. 1 times 4 times 3. That is 12 internships that he now has to pick from. And there you go. That is our notes for today. Doing our sample space, just the list of all possible outcomes, and then we have the fundamental counting principle, which tells us exactly how many things are going to be in our sample space. So make sure that you really understand the difference there. If I ask you for the sample space, I'm looking for an actual list like it was up here. You can pick, if I just ask you what is the sample space, you can have your choice. You can just write them out. You can make a table or you can make a tree diagram. I want to see the list in the sample space. If I just ask you how many possible outcomes, you could make a sample space and then tell me how many there are, or you could just use the fundamental counting principle, multiply your choices together, and tell me how many choices there are. So what I want you to do is to do the 12.01 homework. It is a 2-page document, so it is front and back. We will go over that together next week in the live chat. If you have any questions, message me on Remind. So yeah, have a great day. Have fun.